Hello, this is Mr. Collier, and today we're looking at some patterns and finding a rule for the nth term of a pattern. So if we look at this pattern here, this is the pattern. If we write it out this way, 5, 10, 15, 20, 25, and so on. And n stands for the term number, so this is the first number, second number, and so forth. And we can write it in the table form to show that the first number is 5, the second number is 10, third number is 15, fourth number is 20, and so forth. Okay? So we notice here the numbers are increasing by 5. That's the pattern. So it's easy to get the next number in the pattern because we just add 5. We know the next term is going to be 30. But what about the 50th term or the 100th term? We need a formula for the nth term for that. Well, let's just look at what's happening with the n values. To get from 1 to 5, we need to multiply by 5. Get from 2 to 10, we need to multiply by 5. To get from 3 to 15, so it seems like you always have to multiply by 5. So the rule is going to be 5 times n, or just 5n. Right? It works for 5 here. 5 times 5 is 25, so it works. So if you want to find the 100th term, you just multiply it by 5. If you want to find the 195th term, take 195 times 5. Now let's see if we can figure out the next one. It doesn't look so straightforward, but notice as well, it's also increasing by 5. It's also increasing by 5 each time. By the way, we call that the common difference. So it's increasing by 5 each time. If you look real closely, all of these numbers are just 2 more than the numbers in our previous chart. So our rule for this one can be 5n plus 2, because all the values you have to add 2. Alright, so notice that what we have in common is we have the common difference is plus 5, and then that resulted in a 5 times our term number n. Okay, in this case you didn't have a plus or minus something, but in this case we did. So this is what happens when you're increasing by a constant amount. That constant amount you're increasing by is always the number times n, and then you might have another extra bit as well. So let's take a look at a couple other examples. In this example, we're going up by 6 each time. So you're going to have a similar looking equation with a number times n plus another number. And as we saw before, we were increasing by 5 each time. So in this case, we're increasing by 6 each time. So your formula is going to be 6n, and perhaps plus or minus another number. Now, how do we determine that? Well, if you do use 6n for n equals 1, you get 6. Okay, so 6 doesn't work. You need to get to 8, so you need to add another 2. Okay, so r equals 6n plus 2. You can check it for some of the other values. Let's check it for n equals 4. So if n equals 4, then r equals 6 times 4 plus 2, which is 24 plus 2 is 26. And that works because when n is 4, r is 26. So let's take a look at another example. Looks like the numbers are increasing by 115. Okay, and let's just check to make sure that they're all increasing by 115, and they are. So we have a constant rate of increase. That means again you're going to have this number, the common difference, times n, and maybe plus or minus a number here. So if you look at n equals 1, well, 1 times 115 is 115. We need to get to 110, so you need to subtract 5 in your equation. Okay, and that should work. So we can check n equals 4. So we have r equals 115 times 4 minus 5, which is 460 minus 5, which is 455, just like in our chart. So it looks like our rules work for these two charts. Okay, so notice again, your common difference here is 6, so you have 6n. Your common difference here is 115, so you have 115n. Okay, in our next example, again, I think we have the same type of relationship. So we're adding 4 each time. That's what the pattern is. So the common difference is 4. You're going to have a formula that looks like 4n and maybe plus or minus another number. So if you use 4n on n minus 1, you get 4. You need an extra 3 to get to 7. And let's see if that works for 5. It works for 5 because 4 times 5 is 20, plus 3 is 23, so it works. So there's our rule. And we're going to use the rule to find the 100th term. Okay, so the 100th term is going to be 4 times 100 plus 3, which is 403. So this is our answer to part D. Let's look at this example. Now, what am I adding each time? Well, I'm not really adding. Or you could say that I'm adding a negative 2 each time, or subtracting 2 each time. So that means your common difference is negative 2, and your rule is going to be negative 2 times n. And do we need a plus or minus a number? Well, if we do negative 2 times 1, we get negative 2. What do we need to add to get 4? We need to add 6. So your general rule is negative 2 plus 6, or sorry, negative 2n plus 6 is our general rule. Oops. And part D, use your rule to find a 100th term. We just do negative 2 times 100 plus 6 equals negative 200 plus 6 equals negative 194. Okay, so let's take a look at this example. Now if we try to look for a common difference, we have plus 8, plus 12. What's happening here? Okay, it's not the same common difference, so we can't use the same strategy we did before, but actually we can, because we're not going up by 1 each time. This is not the common difference. We're not going up by 1 each time. So what's happening here is we have some values missing of n here, right? We have the second term, the fourth term, the seventh term. It's not the same. So if it's increasing, the n is increasing by 2 and we're skipping a term, then we could take this difference here, which is 8, and we can actually take 8 divided by 2 to get the common difference. So 8 divided by 2 is 4. Let's see if that works for the next pair. So here n is increasing by 3, and the amount is increasing by 12. So we have 12 divided by 3 also gets you 4. Let's check this one. We have plus 5, and here we have plus 20. Well, 20 divided by 5 is also 4. So that's our common difference. And to find our general rule, well, 4 is our common difference, so it's going to be 4n, and plus or minus something here. So if we do 4 times 2, we get 8. We need to add on another 3 to get 11. So it looks like it's 4n plus 3. We can check with the value here. So 4 times 12 is 48, plus 3 is 51, so it looks like it works. Okay, so that's our general rule. And to find the 100th term, we do 4 times 100 plus 3, which is 403. Let's take a look at one more example. Here we have write down the 6th term of the sequence, so looks like these numbers might have a special pattern. Let's just check the difference here. So we have plus 3, plus 5, plus 7. It's not the same thing each time, so we can't use the same rule to apply. But if we look at it really carefully, 1, 4, 9, 16, 25, you might notice that these are the square numbers. So our next number here is going to be 6 squared, which is 36. So you can't come up with a rule because here we have n is 1, and here we have 1 squared, which is 1. Here we have 2 squared, which is 4. Here we have 3 squared, and so forth. So your general rule, there is no common difference. The general rule is it's going to be n squared. And to find the 100th term, we can do 100 squared, which equals 10,000.